So we're on page 34, and we're going to do problem number 23. So you can see here what we're given is we're given a graph. The y-axis is the value, the x-axis represents the year of purchase, and the graph shows how the value of a car decreases with time. So if this is the initial value of the car when x is 0 over here, we take it out of the showroom, this is the initial value. As time progresses, the value of the car goes down. In this case, we say there's a linear depreciation of a new car. Now, most cars don't show a linear depreciation, but this is a good example of showing, a specific application. So here, after 3 years, we're told that the value of a car is $10,000. After 5 years, we're told the value of the car is $7,500. So these are XY pairs. They're ordered pairs. This is an ordered pair, and that's an ordered pair. And that's the information that we are given. We're just given these two ordered pairs, and we're asked to find the linear equation for the depreciation. Now, you'll notice that in discussing this, in showing this problem, the word linear means that it'll depreciate the same amount going from the beginning to year 1 as it does from going from year 1 to year 2. So it's the same amount. It depreciates by the same amount. In reality, cars depreciate, new cars usually depreciate more in the first couple of years than they do in the last couple of years in their life. So, for example, if you buy a $20,000 car, you may find that when you move it out of the showroom, that in the first year, it goes from $20,000, let's take an example, to $15,000. So it depreciates by $5,000. But let's say you've had the car for 5 years, and it's now worth $10,000. You'll find that from the 5th to the 6th year, it doesn't go down that much. It might go down by $1,000 or $1,500, not the same amount that it goes down in the first year. But anyway, this is a very good example to show a linear relationship if one assumes that there is a linear depreciation of the car. So we have these two ordered pairs here, and the first thing we're asked to do is find the linear equation for the depreciation. In other words, what is the dollar value, the Y value, after years of purchase? And we're going to use this to find what the original purchase price was. And here, right here, is the original purchase price, because this is X is 0 right here. X is 0. And the y-intercept, or B value, gives us, we're going to find this value, gives us what the car was when it was bought. What was the initial value of the car? So that's the B value, and that's the value here. We're going to calculate. What is the value of the car 8 years after purchase? So let's say somewhere around here. We would intersect with a line. Let's say this was 8, and we'd find the value after 8. In how many years will the car have no value? Well, this is when we extend the line way down to where it crosses the x-axis. Because when it crosses the x-axis, y will equal 0, which will mean that it has no value. So we want to know in how many years x will the value be equal to 0. So we need the point at which this line, as it's extended, crosses the x-axis. So as I said to you, these 2 points represents ordered pairs. So this one would be, let's say, x2, y2, and this would be x1, Y1, and we've said that here. 310,000 is X2, Y2, and 5,7,500 is X1, Y1. Don't forget, X is your years and Y is your dollar value. Okay, and that corresponds to the graph here, the Y-axis here and the X-axis here. So if we calculate M and we do the difference in the Y's, 10,000 minus 7,500 over 3 minus 5, we get this, and you can see that this equals minus 1,250, and there's a slight error here, so I'm just going to correct this here and put an equal sign in. Excuse me for a second, that should be minus. So there we have, that should be minus 1250. So what we're saying here is the value of the car is going down by $1,250 each year. The value of the car is going down by $1,250 each year. Okay, so we now know the M value from the difference in the Y's over the difference in the X. We can put this into the point slope form and say Y minus Y1 equals MX minus X1. And we know that M is 1250. So we could put 310,000, one of the sets of the ordered pairs, into this equation. We would get this one right here. And if we put the other set of ordered pair that we were given, 5,7,500, we would come out with equation 2. So we take this equation, we know what M is. In one of the equations, we put 310,000 as X1, Y1 in the point slope form. And in the second one, we put 5,7,500, and we come out with these two equations, 1 and 2. These are exactly the same. They should give the same answer, so it doesn't matter which one we use. We can use either of these two highlighted equations. So part B says, what was the original value of the car? And if you go back, the original purchase price, as I mentioned before here, is where X is 0. So what we want to do is find the value of Y, which is the dollar value. Find the value of Y here in this equation when X is 0. We could do it here also. So let's go equation 1, set X to 0 and calculate Y. Y minus 10,000 equals minus 1250, 0 minus 3, because we're setting X equal to 0 in equation 1. And when we multiply minus 3 times minus 1250, we come out with 3,750. We've got Y minus 10,000 equals 3,750. We transpose the minus 10,000 to the right-hand side, and we get Y equals 10,000 plus 3,750, so it equals 13,750. There's the original value of the car, 13,750. And if we do the same thing on equation 2, we get Y minus 7,500. Here's the equation. Minus 1250, 0 minus 5. 0 minus 5. The minus 1250 times the minus 5 gives us plus 6,250. We still have the Y minus 7,500. We transpose the minus 7,500 to the right side, add it to the 6,250, and we get 13,750. The same thing that we got using equation 1. So whether we use equation 1 or we use equation 2, the original value of the car is 13,750. So if you look at the value, this is this value here. The B value, or the y-intercept, is 13,750. And if you really think about it, if you got 13,750 and it goes down by $1,250 each year, $1,250 after 3 years, it'll go down by $3,750. Well, if you take 13,750 and subtract 3,750, you come out with 10,000. So that's just a little bit of additional information here. Now we're asked to find out what the value of the car is in Part C after 8 years. So we go back and we use equation 1, y minus 10,000 equals minus 1250 x minus 3. X is the number of years, and we're going to substitute 8 because that's what we're given in the problem. And what we get here is that this, we transpose the minus 10,000 to the right, we get plus 10,000, and minus 1250 times 5 gives us minus 6250. So the value of the car is 3750 after 8 years. So you can see that as this line goes down, it goes down, down, down. It makes sense that after 8 years it's certainly going to be less than 7,500. So it's sort of a reasonable answer. We substitute into equation 2 and we do the same thing. We have y minus 7,500 equals minus 1250, 8 minus 5. We get 7,500 when we transpose this to the right side. Minus this 8 minus 5 is 3, so we get minus 3750. 7,500 minus 3750 gives us 3750. Same value. So whether we use equation 1 or equation 2, the value of the car after 8 years is $3,750. The final part of the thing asks us what is the x value when we set y to 0? In other words, when does the value of the car equal $0? We go back over here and we look at the graph right here. We're talking about the extension of the line here. And what is the x value when y equals 0? So what we're going to do is set y equal to 0 in both equations 1 and 2 and figure out what x would be. So we use equation 1, we set y to 0, we get y minus 10,000, there's the original equation, and we set the y to 0, so we got minus 10,000 equals minus 1250, and our unknown here is x, so we're going to solve for x. So what we do is we take the minus 1250 times x, transpose it to the right, we get that, and the minus 10,000 comes over here, becomes plus 10,000, and minus 1250 and minus 3 gives us 3750. So we have 1250x equals 13,750. When we divide 13,750 by 125, we get 11. So after 11 years, the value of the car is 0. Using equation 2, we do the same thing. Here's the basic equation 2, and here we're going to substitute 0. And we want to calculate x. We use the distributive rule to get 1,250 times x gives us minus 1,250x. Minus 5 times minus 1250 gives us 6250. And we move this from the left to the right, we get that. We change the sign. We move the 7,500 from the left to the right. I don't know what I said before. Let me go back over there. This is minus 1250 here that we have on the right. We're going to move it to the left. We get plus 1250, and we're going to move the minus 7,500, which is on the left, to the right. We get plus 7,500. This stays where it is. We get the same thing. 1250x equals 13,750. X is equal to 13,750 divided by 1250. X equals 11. So what we're saying here is that the point at which this line crosses the x-axis is right here, wherever it is, sorry. The point at which it crosses the x-axis will be 11 years. So this is a good example, a practical example of showing how car value, which linearly depreciates, getting some information from the graph itself that we can use.